So hi everyone. In the last part of the lecture, we have discussed different processes in thermodynamics, and we are looking all these processes more carefully. That what will be going to happen. So we have just looked in the last part of the lecture, that is isothermal process. We have calculated the slope of PV curve and how it is there. Now slope is there. Now we need to find out the work done in isothermal process. Okay, so we need to find out the work done in an isothermal process, and work is nothing but work is defined like this. Or work done by the gases P dV. So V1 to V2, where V2 is greater than V1. Now we know what the process is. So we know PV is equals to an RT and temperature is constant. So can we replace P in terms of V? So P is an RT by V. So W comes out to be simply V1 to V2 and RT by V dV, and so an RT ln V2 by V1. So this is work done by the gas. Can we write it like this? No, we should not write like this. We should write like this. If I am saying positive sign, because P is inversely proportional to V. So P1 is equals to an RT by V1, V2 is equals to an RT by V2. Okay, so this is the way. We can also write work done like this, because an RT is P1 V1 or whatever P1 V1 ln P1 by P2, because anyway P1 V1 is equals to P2 V2, so I can use everywhere, and that is equals to an RT. So temperature is constant in 1 and 2, so T is there, T will remain there. So I can write like this, 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 or I can write like so. It is up to the question. So which kind of question is there, but you have to, if you know the process, you will do it. It's very simple. So the work done by the gas is defined like this: W is P dV, where V2 is greater than V1 because gas is expanding, and so we are able to calculate the work done by the gas for isothermal process. Now let's look at the work done slope of PV curve and work done in an adiabatic process. Okay, so adiabatic, as soon as I say adiabatic, it means that delta Q is 0 or Q is 0, however you are defining it. If Q initial is 0, then Q is 0. So we are having a system where you are giving heat so basically it is Q is 0, so there is no heat exchange. So it means that whatever the work you are doing uh, on the gas or the work done by the gas is eventually increasing or decrease in the internal energy of the gas. So the process is so fast that there is no exchange of heat. It is like a like you see thermoflask. So the process is so fast that the expansion is or the work done on the gas is so fast that whatever the work is done by the gas and expanding themselves is just going to decrease its internal energy, and whatever the work is there, that is just simply because of the internal energy. So thermoflask is one of the example where the system is isolated, and so there is no heat transfer and between the walls. Okay, so adiabatic process is defined as PV to the power gamma to be constant. Okay, so PV to the power gamma to be constant means, let's say PV to the power gamma to be K, and hence it's easy to get the slope of the PV curve. So dP V to the power gamma plus gamma V to the power gamma minus 1 dV into P is equals to 0. So dP by dV is nothing but minus P gamma V to the power gamma minus 1 divided by V to the power gamma, and so that is minus gamma P by V. So this is the slope in the adiabatic process. Now we need to calculate the work done. Basically gamma I have already discussed, that is Cp by Cv. Okay, so Cp by Cv is gamma, and gamma is defined as Cp we know, that is or I can write 1 by 2 by F into R. This is how. So this is the slope in the adiabatic process. Now again we need to calculate the work done. So work done is nothing but W is PdV, and we have P V to the power gamma is equals to constant, So P is K by V to the power gamma into dV. So that is K. So we are going from V1 to V2. And K, so this is V to the power minus gamma plus 1 divided by 1 minus gamma V1 to V2. So that is K into V to the power 1 minus gamma divided by 1 minus gamma minus V1 to the power 1 minus gamma divided by 1 minus gamma. K we know, that is P1 V1 to the power gamma is equals to P2 V to the power gamma. So I can write like this here. So I am smartly taking K. With V2 I am taking P2 V2. With V1 I am taking P1 V1. So 1 upon 1 minus gamma, that is P2 V2 gamma V2 minus P1 V1. So that is the work done in adiabatic process. So I hope it is clear. So work done in an adiabatic process is P2 V2 minus P1 V1 divided by 1 minus gamma. So whatever the change in energy is going to the work, and work is calculating. We are calculating work like this. We can also write work in terms of temperature, because temperature is changing. So W is I can write here. So W is we know PV is equals to nRT. So nR by 1 minus gamma T2 minus T1 is my work done in an adiabatic process. So this is done for adiabatic process. Now look at other two simple processes, that are isochoric and isobaric process. So for isochoric process, V is constant, which means that P is directly proportional to T. So if I I wanted to discuss one more thing here. So basically we have discussed till now isothermal and adiabatic process. So we are having P V curve, and I am making two curves here. That is process 1 and that is process 2. You should tell me from this interpretation which curve is for adiabatic and which curve is for isothermal process. So to get that information, we have already calculated the slope of two curves, and the slope of two curves are, so dP by dV for isothermal, that is at constant temperature, is minus P by V, and for adiabatic, that is at constant Q, that is minus gamma P by V. So from that you can understand that which slope is more steep. So here is the gamma factor multiplying, and gamma is greater than 1, therefore the slope for adiabatic process is more steep, and hence we can say that the slope in process 2 is should be greater than slope in, and therefore so second process is adiabatic process and first one is isothermal process. Okay, so this is the comparison that sometimes come in the exam. For the case of isochoric process, we have V is constant. So as I already discussed, V is defined as PdV. So this is eventually go to 0. So for isochoric process, W is 0. So for isobaric process, P is constant, and therefore we have PdV. We know PV is equals to nRT. PV no constant, so we know P is constant, so P, if I integrate V1 to V2, so it is nothing but P V2 minus V1. Okay, so in isochoric process, volume is not changing, so it is like this. In case of isobaric process, pressure is not changing, so if it is V1, it is V2, so this area will give me the work done in isobaric process. So all this is all we have covered, all the processes, all the work done. Let's look at one or two questions. So the question is, that is JEE question. .6 liter of helium at STP is adiabatically compressed to 0.7 liter. Taking initial temperature to be T1, find out the work done in the process. Options are 9/8 RT1, B 3/2 RT1, C 15/8 RT1, and D we have 9/2 RT1. So if you look at this question, the volume is going from 5.6 liter to 0.7 liter, so there is a work done on the system. So signs are all same, so but if the work done is on the system, so according to the physics it should be negative, so but the signs are same, so we can't do much here. Initial temperature is T1, we need to find out the work done in the process. So work done, we have already discussed the formula for work done when we have temperature. So work done in adiabatic process is nothing but nR divided by 1 minus gamma to T2 minus T1. Okay, so we have T2, we have T1. We need to find out in terms of R. We don't have N. We also don't have T2. So we have two unknowns, N and T2. So the one important thing is given here is STP. Okay, so at one the volume of 1 mole of gas at STP is 22.4 liter. Now we have 5.6 liter. Can we get the moles? Right. So that is 1 divided by 22.4 into 5.6. So moles in 5.6 liter of gas. So that is 737878784. So that is the value of N is 1 by 4. Now we have T1. We need to calculate T2 in terms of T1. So we only know that relation, that is P1 V1 to the power gamma is equals to P2 V2 to the power gamma. But how can we relate it in terms of temperature? So from ideal gas law we know that PV is equals to nRT. So can we replace this here, and so what we get is nRT1 by V1 to the power gamma is equals to nRT2 by V2 to the power gamma, and so T1 V1 to the power gamma minus 1 is equals to T2 V2 to the power gamma minus 1. We know the volumes V1 and V2, so that's why I am calculating in this way. So V1 is 5.6, V2 is 0.7. So I want to find T2 in terms of T1. So T2 is T1 into V1 by V2 to the power gamma minus 1, and so T1 is T1. Let's put it this way, and V1 is 5.6 divided by 0.7 gamma minus 1. Gamma, we also don't have gamma. So for helium is a monoatomic gas, and we know 1 by 2 by F into R is gamma. So let us I like to check one thing. So this R should not be there because it is the ratio. So gamma is for monoatomic gas, helium is monoatomic, and therefore F is 3. So 1 plus 2 by 3, that is 5 by 3. So that is 5 by 3 minus 1. So this is T1 into 2 to the power 2 by 3. Okay, so T2 we get T1 into 8 to the power 2 by 3, and so it's 8. So that is 4T1. So now we have T2, we have N. Let's put it here. So W is N is 1 by 4, R divided by 1 minus gamma, that is 1 minus 5 by 3 into T2 T2 is 4T1, that is 4T1 minus T1, so that is 3 by 8 R T1, that is coming in minus, and into 3, that is 9 R T1 by 8. Minus sign is not there in any way, so it is assumed that the correct answer is this. Okay, so I hope everything is clear with this lecture. Thank you for this.